Mathematica and the Raspberry Pi. DSolve and first-order ordinary differential equations. We will use Kirchhoff's voltage law to write the differential equations which describe the behavior of a sinusoidally driven RC circuit. In the first example, we'll solve the differential equations for capacitor voltage and plot the voltage and current waveforms. In the second example, we'll solve the differential equation for circuit current and then plot the voltage and current waveforms. Here's the circuit and its parameters. Be sure to clear all the variables, otherwise you may get some unexpected results. The DSolve function has many components. The first is the differential equation itself. This is followed by the initial condition. These two terms are separated by a comma and are enclosed in curly brackets. This is followed by the variable that we're trying to solve for. In this case, it's voltage on the capacitor. And finally, it's followed by the independent variable t for time. We conclude by using the /simplify command to reduce the output into the minimum number of terms possible. And run it. And this is the answer. So copy and paste it and set it equal to voltage on the capacitor. We can now define all the independent variables. We can now plot the voltage across the capacitor, resistor, and voltage source. We can now add plot attributes to make the plot more meaningful. Since we know all of the circuit voltages, we can now calculate the circuit current and plot it. Alternatively, we could have come to the same result by solving the ordinary differential equation for circuit current. This is a little bit more complicated because it requires that we take the derivative of the source voltage as well. In this case, we'll use the full simplify command because it gives us a slightly better result than using the simplify command. Again, we copy and paste the DSolve solution. We can also do the same with the various variables, and also with the various plot command functions. We can now define and plot the various circuit voltages. And there you have it. Using DSolve on both equations ends up with exactly the same results.